At this time, I'd like to introduce our presenter, Richard Roberts. Richard is Industry Affairs Manager for System Sensor and Honeywell Fire Systems. Richard, take it away.
Thank you, David. Good morning or good afternoon, depending on which time zone you're in. I'd like to thank everybody for taking time from their busy schedules to attend today's informative presentation. Even though this webinar is being presented by System Sensor, it is not a product sales pitch. Rather, it's an unbiased presentation about the various studies that have concluded a low-frequency audible alarm signal is most effective for waking up people who are hard of hearing, school-age children, the alcohol-impaired, and the elderly. At the end of today's presentation, you'll know the difference between a low-frequency signal and the standard audible fire alarm signal, and you'll know when and where the low-frequency signal is required. During the next 45 to 60 minutes, we'll go over the reports that show how smoke detection and fire alarm systems have reduced fire fatalities in the last 35 years, as well as discussing some of the challenges facing smoke detection and fire alarm systems. We'll review the new low-frequency requirements in NFPA 72, NFPA 720, and several UL product standards. Lastly, we'll cover several occupancies that will require the low-frequency signal to be installed after January 1st, 2014. So let's get started. I'd like to begin by reviewing the various studies that show how smoke detection and fire alarm systems have reduced the number of fatalities in dwelling units as well as buildings in the last 35 years. Smoke alarms and smoke detectors are designed to detect a fire in its early stages and alert people so they have time to escape the dwelling unit or building safely. According to numerous NFPA reports, home fire fatalities in the U.S. have decreased from slightly over 6,000 in 1978 to 2,644 in 2010. Now that's an overall reduction of 44%. Now NFPA classifies homes as 1- and 2-family dwellings, manufactured homes, or multifamily housing. Non-home fire fatalities have decreased as well. According to a U.S. Fire Administration report, non-home fire fatalities declined from 640 in 1977 to 120 in 2011. Looking at hotel and motel structure fires, fatalities have declined from 62 in 1980 to 16 in 2010. Now, it's important to point out that not all of the reduction in the fatalities can be attributed to the use of smoke detection or fire alarm systems. However, many researchers agree that they have contributed to these substantial reductions because 22% of U.S. homes had smoke alarms in 1977, and as of 2010, 96% of homes surveyed had at least one smoke alarm. So as you can see, properly installed smoke alarms, smoke detectors, and fire alarm systems can mean the difference between life and death during a fire. Now, even though fire fatalities have seen significant reduction, there still remain challenges to overcome. For instance, there are several factors that limit an occupant's ability to safely escape from a threatening fire, even if the fire alarm system or the smoke detectors are operating properly. Let me explain. The amount of time people need to safely exit a dwelling unit or a building is one factor. Predicting escape time is embodied in the concept of required safe egress time, or more commonly referred to as RSET, and available safe egress time, or more commonly referred to as ASET. Now let's look at RSET. It involves estimating the time it takes people to be notified there is a fire, along with the time it takes them for activities such as checking on family members and the time it takes to exit the structure through the normal path of egress. Whereas ASET is the time when the detector goes into alarm until the start of untenable conditions, that prevent people from safely exiting the occupancy, such as visibility from smoke is less than 10 meters, temperature is above 60 degrees Celsius, and when carbon monoxide concentrations are above 800 ppm for a short period of time. The problem is when ASET is reduced, that means people have less time to safely exit the occupancy. Now, the second factor that we're going to look at is how effective is the standard audible fire alarm signal at waking up high-risk segments of the population during a fire. Now, several examples of high-risk groups of people or occupants are school-aged children, the elderly, people with hearing loss, and the alcohol impaired. If these high-risk groups are not able to hear the audible fire alarm signal, they will not be able to safely exit the dwelling unit or building, even though a smoke alarm or smoke detector is operating properly. Now, in the last 35 years, we've seen considerable changes in dwelling units and buildings. Today, the average home is much larger than it was in the 1970s. According to a U.S. Census report, the average square footage of a home has increased from 1,660 square feet in 1973 to 2,392 square feet in 2010. Now, it goes without saying, a larger home will have more stuff inside, which means the fuel load in the home has increased, and that will mean the fire will be more intense. During the mid-1980s, construction methods changed from using real wood lumber like 2x4s, 2x6s, and 2x12s that are used for studs, trusses, and joists to engineered lumber made from wood and synthetic epoxies. Although the engineered lumber under normal use is lighter, less costly, and just as strong as real wood, studies have clearly demonstrated that during a fire condition, the engineered lumber burns faster and collapses much sooner than real wood. Therefore, it's imperative for occupants to exit a building that's constructed or partially constructed of engineered lumber as soon as possible. Also, the type of interior furnishings found in homes, hotel guest rooms, dormitories, and offices have changed as well. Petroleum-based synthetic materials have replaced natural materials used in furnishings. Most furniture available today utilizes polyurethane foam for padding, polyurethane or polyester or nylon for furniture coverings, carpet, and drapes. Because synthetic materials are easier to clean and more resistant to normal wear and tear, they have replaced natural materials like cotton, wood, wool, linen, and silk. With the combination of increased building size, with increased fuel loads, and the widespread use of synthetic materials, smoke characteristics of fires today are considerably different than in the 1970s. In the next several slides, we will review the various reports that show how synthetic materials generate higher heat, more smoke, and they ignite and burn faster than natural materials that were used in the past. Reports will also show that people have less available safe egress time because of the use of these synthetic materials. There are two research studies conducted by the National Institute of Standards and Technology, more commonly referred to as NIST, that show how fires today burn hotter and faster and people have less time to safely escape than they did in the 1970s. The studies use smoke detectors in residential homes to determine the amount of escape time people would need to safely exit the dwelling. Now, the first NIST study conducted a series of tests from 1974 to 1976 in residential homes that were scheduled for demolition as part of the expansion of the Indiana Dunes National Lakeshore Park. The report is commonly referred to as Dunes 1. The study used furnishings manufactured in the 1960s and the 1970s. These furnishings were made of natural materials like cotton, wood, wool, linen, and silk. The report presented the results in the amount of time people in a dwelling need to escape using the primary escape path. Available safe egress time, or ASAT, was measured from the time the detector went into alarm until the room's condition reached one of the defined tenability limits that we talked about in the previous slide, that being smoke density, temperature, and CO concentration. The study concluded people had 17 minutes of available safe egress time in a flaming fire, and the smoke alarms provide adequate escape time in 90% of the fires. After 30 years after the original Dunes 1 research, the industry and members of the fire service community questioned whether the data would change when modern synthetic materials were used with current smoke detection technologies. This question led to a second NIST study known as Dunes 2. The research project was similar to the original Dunes 1 project, except the furnishings were constructed of modern synthetic materials and used more advanced instrumentation to monitor and record data. Now, in the Dunes 2 project, the Dunes 1 data served as a baseline for comparison. The average available safe egress time for smoldering fires in both Dunes 1 and Dunes 2 were similar. The results also confirmed the new synthetic furnishings and building materials burn hotter and faster than fires in the 1970s. However, there was one finding in the Dunes 2 report that was critically different than the original Dunes 1 study. The window of available safe egress time in flaming fires was only 3 minutes compared to 17 minutes in the Dunes 1 study. NIST noted that early detection in these types of fires is critical to allow occupants the best possible chance of escape. The study also concluded that properly installed and maintained smoke detection still provides enough escape time in most fire scenarios. Now, to really understand the difference between a legacy room and a modern home furnishings, UL conducted 2 full-scale fire tests in 2009. Now, in the next several slides, we'll show several screenshots of the different stages of the 2 fires. Now, if you'd like to view the full video, you can go to the YouTube link that's referenced at the bottom of the screen to view the entire video. Okay, both rooms measure 12 foot by 12 foot with an 8-foot ceiling and contain similar amounts of like furnishings. The legacy room on the left contained furnishings made of natural materials such as wood, wool, linen, and silk, whereas the modern room contained furnishings made of synthetic materials. Both rooms were ignited by placing a lit candle on the right side of the sofa, and the fires were allowed to grow until flashover. At 1 minute 30 seconds, the flames in the modern room are clearly visible, whereas the fire in the legacy room is just beginning to show signs of a flame. At 2 minutes 30 seconds, the fire in the modern room is growing very rapidly and black smoke has already covered the ceiling. The flames in the legacy room are just really becoming visible. And finally, at 3 minutes 30 seconds, the modern room transitioned to flashover, whereas the flames in the legacy room is still not very prominent. The legacy room does not transition to flashover until 29 minutes 30 seconds. Now, when a fire reaches flashover, there is absolutely no chance of anybody surviving or getting out of the house. So the takeaway here is the window of available safe egress time in flaming fires today is only 3 minutes compared to 17 minutes in 1976. Okay, let's turn our attention to looking at waking effectiveness. Smoke alarms and fire alarm systems provide value when occupants are awake, but their greatest benefit may be when occupants are asleep. This is illustrated in a 2010 U.S. Fire Administration study that reports 50% of fire fatalities in residential buildings occur between the hours of 10 p.m. and 6 a.m., time when people are usually sleeping. And according to a 2008 Dorothy Brooks study, most unimpaired adults wake up quickly to the standard audible fire alarm signal, even at levels well below 75 dBA. Before going further, let's understand what a standard audible fire alarm signal is. The majority of fire alarm horns produce a signal with a frequency range between 2 kilohertz and 4 kilohertz. Also, the integral sounder in nearly all smoke alarms or smoke detectors produce a 3 kilohertz audible alarm signal. So when I refer to a standard alarm signal, or the studies refer to a standard alarm signal, it's a signal with a frequency range in the 3 kilohertz area. If most unimpaired adults wake up quickly to the standard audible fire alarm signal, how effective are they? How effective is the standard signal at waking up certain high-risk segments of the population, such as school-age children, the elderly, and people with hearing loss? According to a U.S. Fire Administration study, the age of 13% of fire fatalities in residential buildings are less than 10 years old, and 44% of the fatalities are between the ages of 40 and 69. Also, there are more than 34.5 million people in the U.S. who are hard of hearing. Now, during the next several slides, we'll demonstrate that the standard fire alarm signal is substantially less effective at waking up people than other signals tested. The 2008 Dorothy Brooks study ran numerous experiments using different types of signals to determine the waking effectiveness for healthy adults in the high-risk groups and high-risk groups. The signals tested were a low-frequency signal with a 520 hertz band, the standard 3 kilohertz alarm signal, bed and pillow shakers, and lastly, strobe lights. Of all the signals tested, the low-frequency signal with a fundamental frequency of 520 hertz was most effective in waking up the majority of participants. Specifically, the low-frequency signal was 6 to 10 times more effective at waking up people than the standard alarm signal. In adults with hearing loss, it was more than 6 times as effective as the standard signal and more effective than bed and pillow shakers. And lastly, strobe lights were found to have very poor waking effectiveness. Okay, David, it looks like we're ready for our first break.
Very good, Richard. Thank you for that. So you'll see shortly a poll question come up on your screen, and we'd love your help in helping answer this. So what edition of NFPA 72 are you currently or presently using for design or enforcement? 02, 07, 10, 13, or other. And if you do pick other, can you use the questions box on your GoToWebinar control panel and tell us why you picked other? We did do a similar a webinar on Tuesday, and other comments might have been, well, I cover multiple jurisdictions, I cross state lines. States have different, I might be in 10 in one and 7 or 13 in another one. So what's your reason for picking other, if you would? So go ahead and vote. Richard, we do have a couple questions that have floated in.
Okay.
The first one is, do we know what manufacturers currently offer a low-frequency product?
Obviously, System Sensor just recently introduced a low-frequency horn. I'm not aware of any other manufacturer that has a system-connected horn or a system-connected smoke detector with a low-frequency signal, horn with a low-frequency signal.
Okay.
There may be, but to my knowledge, I'm not aware of any.
Okay, good. We have a second question, and I think I can answer this one. There's obviously the cost question comes up, and our low-frequency sounders priced more or less than, say, an average horn. And I believe the correct answer is always to check with your local dealer or distributor for final pricing. But yes, on average, the low-frequency sounder will be slightly more money than a standard horn due to that complexity of design. So Richard, a bunch of people have commented here. Thank you so much. We've got a big audience, over 700 people online with us today, so thank you for joining us too. They're saying the answers to their questions varies by AHJ territory. One guy's dealing with 02, 07, and 10. Another one's dealing with IFC 2013, and we'll be using IFC 2015 next July. Multiple editions based on their market area, so that makes sense. We've heard that before. They're using both 10 and 13, so a number of those. Some are government, Air Force base, and public sector. Air Force is on 2013, but public sector is 2010. So a lot of comments around these lines. So very good. You know, I don't think I told you this, but I'm actually going to share these poll results with you so you can see how some of your commercial fire industry brothers and sisters are doing here. So Richard, it looks like 53%, clear majority are in the 2010. So if you put 2010 and 2013, which would be affected by this new code change, you're looking at 67, exactly 70% of the audience attending today will be impacted. Balance really is 2007 at 20 and 2002 at 5, and then the others, which I mentioned several of those already. Let me take down those poll results, and Richard, we'll be back to you.
Okay, thank you, David. And actually, I'll get into it in a few minutes in the presentation, but as more and more states adopt the 2012 edition of the International Fire Code or International Building Code, that will in turn mean the adoption of the 2010 edition of 72. So those numbers that you just reported will only increase in the future. So, okay, back to the presentation. Based on the numerous studies we've just reviewed, many NFPA 72 committee members were very concerned about how effective the standard 3 kilohertz alarm signal is at waking up people with hearing loss, the elderly, school-aged children, and the alcohol impaired. So in 2006, the NFPA petitioned the Fire Protection Research Foundation to carry out 2 research projects to study the effectiveness of the audible fire alarm signal in high-risk groups. The studies were, first, waking effectiveness of alarms for adults who are hard of hearing, and the second one was waking effectiveness of alarms for the alcohol impaired. Now, the aim of the 2 studies is to optimize the performance requirements to meet the needs of these high-risk groups. The FPRF studies examined a total of 38 volunteers aged between 18 and 77 years old. 16 were males, 22 were females. Now, each participant was exposed to a range of signals across a non-consecutive 2-night period while they were asleep. The 6 signals tested were a 400 hertz signal, a 520 hertz low-frequency signal, the standard 3 kilohertz alarm signal, a bed shaker, a pillow shaker, and finally a strobe light. The 2 studies came to the following conclusions. The low-frequency 520 hertz signal is most effective by waking up 92% of hard-of-hearing participants when presented at 75 dBA for 30 seconds. Whereas the standard 3 kilohertz signal woke up only about 56% at or below 75 dBA. The low-frequency signal is superior to bed shakers, pillow shakers, and strobe lights. Now, I've talked a lot about the standard 3 kilohertz alarm signal versus the low-frequency 520 hertz signal. If you click on the link at the bottom of the screen, you'll be able to listen to both signals and hear the difference. By doing that, you'll notice 2 things. First, the 520 hertz signal has a lower tone than the standard alarm signal. And secondly, both signals have the same temporal 3 fire alarm evacuation pattern. So finally, after reviewing all the background, the history of all the studies that led to the low frequency signal, let's look at the actual requirements in NFPA 72. The low frequency requirements are found in 3 chapters, Chapter 18, Chapter 24, and Chapter 29. Now, looking at Chapter 18, it covers the audible alarm signal that is part of a protected premise fire alarm system. The requirements in Chapter 8 do not cover the audible alarm signal produced by a smoke alarm or a household fire alarm system. Chapter 24 covers emergency communication systems such as in-building fire voice evacuation systems and in-building mass notification systems. And lastly, Chapter 29 covers all the occupancies that are required to install smoke alarms or household fire alarm systems. Effective January 1st, 2014, Section 18453 requires the low-frequency signal in all areas to wake up people sleeping in occupancies having a protected premise fire alarm system. Several examples are guest rooms of hotels, dormitory sleeping rooms, and possibly dwelling unit bedrooms within apartment buildings. This requirement does exclude hospital patient rooms and other occupancies where the signal is not intended to wake up people sleeping. These types of occupancies have trained staff that's responsible for waking up the patients. Also, the Chapter 18 committee chose to apply the requirement to all sleeping areas, not just those where occupants have self-identified as having a hearing impairment. This was done intentionally for several reasons, such as people may not know they have a hearing impairment, and the fact that the low-frequency signal has proven very effective at waking up people with alcohol impairments. The 2010 requirements that we just covered do carry over into the 2013 edition of the standard. However, the Chapter 18 committee revised the wording slightly to clearly convey the low-frequency signal is intended to awaken people who are sleeping only. For example, the low-frequency signal is not required in the hallway of a hotel, but is required in the hotel guest room. The compliance date in the 2013 edition is still January 1st, 2014. Okay, let's look at the Chapter 24 requirements. These 2 sections on the screen cover occupancies that use a voice system for occupant notification instead of horns. Section 24.4242 requires a low-frequency signal in sleeping areas to be followed by a voice message to communicate information to people who could be asleep, except in occupancies listed in or referenced in 24.4243. The reason for this provision is to comply with the NFPA 72 and UL 864 requirement for the voice evacuation message to be preceded by 2 cycles of the Temp 3 audible alarm signal. Now, looking at Section 24.4243, it does not require the low-frequency signal in occupancies where the voice system is used to communicate to occupants who are awake. For example, again, in a hospital, the voice message is used to notify staff members who are already awake. The staff will then respond to the appropriate location in the hospital to carry out their duties that could include waking and or relocating patients who could be in danger. Low-frequency requirements have been added for household fire alarm systems and single and multiple station smoke alarms. In accordance with Section 29388 and 29381, the low-frequency signal is required in sleeping areas for people with mild to severe hearing loss, where required by governing laws, codes, or standards, and lastly, where provided voluntarily for people with hearing loss. Now that begs the question, what is mild to severe hearing loss? NFPA defines hearing loss as full or partial decrease in the ability to detect or comprehend sounds. The annex in NFPA 72 goes on to say that hearing loss can be ranked as either mild, moderate, severe, or profound. The severity of the hearing loss is measured in decibels before being detected by an individual. So, to be classified as mild, adults must lose between 25 and 40 dB. For severe, they must lose between 71 and 90 dB. I should also mention that because the low-frequency signal is not acceptable for people with profound hearing loss, Section 29382 requires both visible and tactile notification appliances for people with moderately severe to profound hearing loss. Tactile notification appliances such as bed and pillow shakers are effective at waking up people, but visible appliances are also needed because people sleeping may not always be in contact with the tactile notification appliance. Unfortunately, Section 2936 in the 2010 edition of 72 required a low-frequency signal in all sleeping areas by referencing back to Section 1845. If you remember from a few slides ago, 18453 requires the low-frequency signal in all occupancies. It was never the intent of the Chapter 29 committee to require the low-frequency signal in all sleeping areas. Rather, their intention was for the signal to be required in sleeping spaces where there is a need to awaken people with hearing loss. So the committee corrected this oversight through a tentative interim amendment, or typically referred to as a TIA, for the 2010 edition by requiring the low-frequency signal in sleeping areas to awaken people with hearing loss only. The committee incorporated the 2010 TIA language into the 2013 edition of the code. So now both the 2010 and 2013 editions for Chapter 29 have the same requirements. So to summarize the NFPA 72 low-frequency requirements, Chapter 18 and Chapter 29 have different scopes. Chapter 18 requires a low-frequency signal in all sleeping areas to wake up people sleeping in occupancies having a protected premise fire alarm system. Unlike Chapter 18, Chapter 29 does not require the low frequency in all areas where people sleep. Instead, Chapter 29 requires the low-frequency signal in all areas to wake up people with hearing loss only. Also, the scope of 29 covers occupancies where smoke alarms, not detectors, but smoke alarms or household fire alarm systems are installed. Okay, looking at, switching gears here and looking at NFPA 720, which is the standard for the installation of carbon monoxide detection and warning equipment, except for a different effective date and a different temporal pattern. The 2012 edition of NFPA 720 has the same low-frequency requirements as NFPA 72 does for a fire alarm system. So effective January 1st, 2015, Section 6443 requires the low-frequency signal to wake up people who are sleeping in all occupancies having a protected premise CO detection system. Low-frequency requirements have been added to Chapter 9 of 720 as well. I should point out that Chapter 29 covers all occupancies that are required to install CO alarms or household CO detection systems. Section 942211 requires a low-frequency signal in sleeping areas for people with mild to severe hearing loss where required by governing laws, codes, or standards, and lastly, where provided voluntarily for people with hearing loss. In April of 2012, UL published revisions to several product standards with new low-frequency requirements. Horns listed as complying with UL 464 must be marked with the following wording, either low-frequency alarm or low-frequency sounder on the housing of the unit. For smoke alarms, the wording, or smoke detectors, the wording low frequency alarm must be on the exterior of the housing. Now, the key takeaway here is, first, manufacturers are now able to design, manufacture, and list product for low frequency application. And secondly, installers and code enforcers need to look for the wording low frequency alarm or low frequency sounder on their horn or smoke alarm to make sure that it is compliant. Okay, David, it looks like we're ready for another break.
All right, very good. Hey, not a break. This is where we put our attendees to work here. So what I'd like to do is launch the next poll question here. So you've told us a little bit about when your jurisdiction, or what NFPA 72 or IFC jurisdiction you're under. So when do you think you'll be required to meet the low frequency requirements? Maybe sometime in the next 6 months? Is it effective in your area? By January, 6 to 2 years, and you can think 6 to 12 months, 6 months to 2 years. More than 2 years, maybe it's unlikely that you'll ever have to meet this requirement. And again, like you did before and you responded so well previously, if you do pick other, use that questions box on the GoToWebinar control panel and indicate what other means to you. We've got about 53% of you that have voted so far. Richard, we do have a bunch of other questions here. Let me just go through some of them. Are the low-frequency sounders required for retrofit applications? And we've had the same question asked, existing construction. So what do we say? What is the code saying about that?
Excellent question, and actually that's one that I receive quite frequently. And the requirements in NFPA 72 and Chapter 907.2 of the IFC, which we'll get to here in just a minute, do not apply retroactively to existing systems. However, there are situations where an AHJ may require an existing system needs to be brought up to current criteria, even though the system still meets the minimum requirements of the version of the code that was in effect at the time of the original installation. For example, changes to an existing system, such as replacing a significant portion or all of the components of a system, and the AHJ may determine that an existing system may present a hazard to life or property. So, it's the 72 and the IFC, Section 907.2, don't apply retroactively to existing systems. However, if you're working on a project, it's always wise and highly recommended that you consult with your local AHJ before actually bidding on the job or beginning the installation.
Okay. Richard, we know that this new code will apply to hotel, motel, sleeping spaces, retirement assisted living areas, sleeping spaces specifically, dormitory sleeping spaces, apartment condo sleeping spaces. A gentleman here has a question: is the requirement that the tones in these spaces be the same between that sleeping space and the hallway?
No, as long as you use a horn or smoke alarm that's listed for the low frequency application. UL requires all the products listed for low frequency to have the words low frequency alarm on the housing. The 520 hertz is required in the sleeping unit, but not in the corridor of a hotel or a dormitory.
Okay, very good. As always, I'm going to close the poll here. Thank you for 78% of you to vote. We do appreciate that, and I'll share the results with you. So, Richard, seems like similar to those that are impacted by 2010 and 2013 NFPA 72, that is, 2010 and 2013. We've got about 31% that are within the next 6 months will be immediately impacted by that. 44% are indicating 6 months to 2 years, and you can see the other results there. And then those that did pick other, we had about 6% of our audience here that picked other, and kind of similar responses to the first question. So it varies by jurisdiction, maybe even varies by AHJ. There is a comment here that I want to turn into a form of a question. The gentleman says I won't be affected until it's in the IFC. I guess in terms of a question, is the IFC also looking at low frequency?
Excellent question. If you just wait a few minutes, I will get into that and start talking about the IFC and the IBC.
Very good.
Yeah, I don't want to steal my own thunder here, so we'll get to that in just a minute.
Not a problem. So we took the poll question down. So Richard, back to you.
Oh, okay. Thank you, David. Okay. Hopefully this will answer the person's question that just asked. Let's look at several Group R occupancies that will be required to have the low-frequency signal installed after January 1st, 2014. Now, to do that, we need to turn our attention to the 2012 edition of the International Fire Code and the International Building Code. So, looking at Section 907.2 in the 2012 edition of the IFC IBC, it requires a fire alarm system to be installed in new buildings in accordance with NFPA 72 and provide occupant notification in accordance with Section 907.5. Now, 907.5 requires the activation of a fire alarm system to send a signal to the control unit and then provide occupant notification throughout all occupied areas of a building, including both common and tenant spaces. Now, obviously, common spaces are corridors, lobbies, or meeting rooms within hotels. Tenant spaces are dwelling units within apartment buildings, guest rooms of hotels, or dormitory sleeping rooms. The basic purpose of a fire alarm system is to alert all occupants in the building. Now, I'd like to point out, again, to stress this, that the requirements in 72 and Section 907.2 of the IFC IBC do not apply retroactively to existing systems. However, there are situations where an AHJ may require an existing system needs to be brought up to the current code. So, as I said a minute ago, you really need to, when it involves existing systems, you really need to consult with your local AHJ to make sure you both are on the same page. Okay, the 2010 edition of NFPA 72 is referenced in Chapter 80 of the IFC and Chapter 35 of the International Building Code. And finally, as we discussed a few slides ago, Section 18453 and 72 requires the low-frequency signal in all occupancies having a protected premise fire alarm system to wake up people who are sleeping. So as you can see, we sort of indirectly get to 72 by looking at the requirements in the International Fire Code and International Building Code. So what are the Group R occupancies that will require the low-frequency signal? The low-frequency signal will be required to be installed in sleeping units of motels and hotels where there is a protected premise fire alarm system to activate the occupant notification system. As I mentioned a few slides ago, the purpose of the protected premise system is to alert all occupants in the building, including sleeping units. However, Exception 1 of 907.281 exempts a protected premise fire alarm system from being installed in buildings that are not more than 2 stories or where individual sleeping units have an exit directly to the public way. The low-frequency signal is also required to be installed in sleeping units of colleges and universities where there is a protected premise fire alarm system to activate the occupant notification system. So to summarize the requirements in the IFC IBC as it applies to low frequency, the low-frequency signal is required in sleeping units of newly constructed motels, colleges, and universities where there is a protected premise fire alarm system in the building. Okay, David, I'll turn it back to you so we can answer as many questions as possible as time allows.
All right. Thank you, Richard. Appreciate it. And while we're answering some questions here, we're going to leave this following poll question up. We'll probably leave it up for 4 or 5 minutes, so take advantage of it if there's something that we can help you with. We'd love to send you some information, those first 4 items, something we could send to you electronically. So if you'd like to see the system sensor low frequency sounder or sounder strobe data sheet, perhaps the sounder requirements fact sheet, sounder engineering specs, maybe the link to the web page that lists all the low frequency sounders, or if you'd like to speak with a system sensor representative, go ahead and check multiple options if you'd like. You can check all 5 or check 1, whatever, anything in between. So we do have some questions here, Richard. Actually, we have quite a few questions, and we will work till the top of the hour to finish these. Next question, in fact, several people have asked this about synchronization. Does the system sensor low frequency sounders synchronize with standard horns?
They do synchronize with other system sensor horns.
Okay.
Yes.
All right. And I just answered this question online, so if you saw that come through recently, but will System Sensor offer a version of low frequency sounder base? And the answer is yes, we're working on it. It should be available before year end next year, and that'll be compatible with our 200 series smoke detectors. So Richard, let's see. Our requirements, let's see, wait a minute, let me just interpret this text. Are low frequency sounders also required in hallways of sleeping areas?
No, because as I said, the requirements are intended to wake up people who are sleeping, and people in hallways, it's not intended for people to be sleeping in hallways. So
not usually,
unless they're passed out in a hallway of a hotel room or a dormitory. But it's only required for the in sleeping areas to wake up people who are sleeping.
Okay, kind of a specific one here. Will we, so we being the fire community, will we be required to verify the 520 hertz square wave tone during our inspection process?
Excellent question, and the answer is no, because as long as there's listed horns installed, they should, produce the 520 hertz signal. But you're still required to verify the proper audibility in the sleeping area. And in Chapter 18, it does say or require that the audible fire alarm tone to wake up people, that it must be 75 dB at the pillow. So at the time of installation, the only thing that you need to verify is that there's sufficient audibility at the pillow, but you will not have to confirm the low frequency requirement if listed product is installed.
Okay, very good. So go ahead and indicate how we can help you. I'll leave that up for one more question here. I'll take it down, and then you'll see Richard's contact information. But Richard, next question. Can you meet the low frequency requirements with a voice evac system?
Ooh. Very good question, and that's one that I'm starting to get asked quite frequently. Excuse me. Yes, the use of speakers and amplifiers is another way to accomplish the low frequency signal. Obviously, you can accomplish it with a listed horn. However, it's UL's position for voice systems to test the panel, the amplifier, speaker, and sound file to the low frequency performance requirements that's listed in UL 864. Speakers and amplifiers can be listed within a frequency range to the applicable product standard from 400 to 4,000 kilohertz. Now, yes, the 520 hertz signal does fall within this frequency range, but the difference is that the speaker and amplifier product standards test the performance as an average over the manufacturer's specified frequency range, whereas the low frequency requirements in UL 464 verifies that the products meet the frequency, response, and harmonics at 520 hertz. Unfortunately, the current edition of UL 864 has no low frequency requirements, but there is a proposal to add low frequency requirements for the next edition of 864. So,
okay.
Yeah, it's kind of a long answer, but you can use speakers, but it has to be listed for low frequency application.
Okay, I think you've been asked that question before. You were ready.
I kind of anticipated that this was coming up because,
yep.
as I said, over the last couple months, I have really received that question quite frequently.
Yep. Do know, those in our audience, that Rebecca Peterson's a product manager with us, and she is answering some questions online as well, while Richard is answering them verbally here. So, any answers coming through you might be seeing that are coming from Rebecca. Richard, next question. Do low-frequency sounders draw more current than standard sounders? I think Rebecca's answered that online, but maybe just verbally, what's the right answer?
Yes, they do draw more current. What the, how much more, I really don't know. What I would recommend that you do is, go on systemsensor.com and, go to our web page, look at it, and you'll be able to, compare the difference between the low-frequency horn versus the standard 3 kilohertz horn.
Okay. He's asking for some clarification. Is it true that standalone smoke alarms for R1 and R2s don't have to produce low-frequency signals?
If the smoke alarm is installed in a sleeping room of a, for example, a hotel, and the hotel does not have a protected premise fire alarm system, it'd be a very, very small, probably more like a motel, a 1- or 2-story motel. I would say yes, it would be required to have the low frequency signal.
Okay. A couple questions here on the code applicability to commercial or residential. Does it apply to both, or where will this be impacting?
It really applies to both. As I said, Chapter 18, talks about, or the scope of it covers all occupancies that have a protected premise fire alarm system, such as a hotel, motel, dormitories, and multi-family housing. But Chapter 29 covers smoke alarms and household fire alarm systems. And Chapter 29 only requires it for people that have hearing loss.
Okay. All right. Question about E occupancy. So are low-frequency sounders required in E occupant areas, such as daycares?
Good question. One that I haven't received before.
Okay.
Right off the top of my head, though, I mean, if there are designated sleeping areas, I would, yeah, but typically daycare occupancies, you have, quote, staff at the premise that is, responsible for waking up kids. So, I would say that would fall into an occupancy such as a hotel, or a hospital, and hospitals are not required to have the low-frequency signal, even though you have patients sleeping there, and that's because you have trained staff to wake these people up and relocate them if necessary. So I would say the same holds true for Group E occupancies.
Okay. All right. Another clarifying question: are low-frequency devices required in all sleeping rooms or those designated for the hearing impaired?
If it falls under a Group R occupancy and it has a protected premise fire alarm system, which falls under the scope of Chapter 29 of 72, it's all sleeping areas.
Okay, all right. Next question. It's a why wouldn't you question. Why wouldn't you use low-frequency sounders in hallways as well as sleeping spaces to keep all the sounders uniform? Any reason for or against?
Certainly there's nothing to prohibit the installation of low-frequency sounders throughout an entire occupancy. But the Chapter 18 committee of NFPA 72 only requires the low-frequency signal to wake up people who are sleeping. So, for example, in guest rooms of hotels or sleeping units in dormitories, it's only required in the sleeping area. It is not required in the common areas such as corridors or elevator lobbies or meeting rooms. But there's nothing in there that prohibits installing it throughout the entire occupancy.
Yep. Okay. Maybe a more of a construction-related question. He says he has a customer with a new college dormitory, which is just being completed. It will not, however, be completed until early next year. Does it need to comply with the low frequency since construction will be completed after 1/1/2004 or 2014? Sounds like a question for his AHJ, but you want to weigh in?
Yeah. Essentially, he has to go back to his AHJ, but typically, when a new state or municipality building code becomes effective, that is usually when that does not pertain to buildings that are already being constructed or the permit wasn't or was pulled prior to the new effective date. So, for example, in California, I believe the new California Fire Code, California Building Code, the new effective date is January 1st, 2014, and any building that had a permit pulled prior to or plans approved prior to January 1st, 2014 will not be impacted by it.
Okay, very good. They're wondering here, let's do one more question. Looks like till the top of the hour. Can the SPR, which is a system sensor model number for one of our speakers, handle the low frequency tone using the fire alarms panel generated low frequency digital voice controller?
Good question, and I sort of touched on it, or I did touch on it in a previous question, and yes, I mean the use of speakers and amplifiers is another way to accomplish the low frequency signal instead of using horns, but it's UL's position that a voice system to be listed for low frequency application, they want to test the panel, the amplifier, the speaker, and the sound file to make sure the complete system is able to generate the specified 520 hertz low frequency signal.
Okay, very good. My clock just turned over the top of the hour, so on behalf of System Sensor, I do want to thank you for joining us today. We do respect your time, so we're going to end the webinar at this point. As a follow-up, we will send you a brief survey in about an hour and would appreciate your help in filling that out. And we will plan to reward one of you that completes the survey with a $50 Amazon gift card. Thank you again for joining us. This does conclude our webinar. Your CEU certificates will be emailed to you, and please have a nice rest of the day.